Hello, this is Bob Dunn with Gibbs & Associates. We're going to give you a demonstration of the Tombstone management system and machine simulation. This will be the first of 3 videos. We're going to go ahead and import a parasolid model. As we do, we're first going to place this onto a 3-axis vertical mill. And we're going to do all of the machining from scratch. And so again, we're on a 3-axis vertical mill. As we go through this, we're going to do a couple of things. Show you 1, the flexibility of the Gibbs CAM system, and 2, also the flexibility of the Tombstone management system. And what I'm doing right now is I'm making the part belong to CS number 2 because later we're going to move this thing around. So we're going to force it to belong to coordinate system number 2, and we can close the coordinate system menu. Now as we jump into this, let's go ahead and pull out a piece of geometry here real quickly. Excuse me. And something to give us the drilling operation. Now opening up the machining menus, we're going into stored processes and we're going to bring in a new drill. It's a 1-inch diameter with the machining process. We're going to machine that hole, and we're going to tell the software we're working on CS number 2, which is named part. And let's go ahead and do it. Now the next thing we need to do is mill the contour around the outside of the part. So we'll replace process number 1 with process number 2. This will be a 1/2-inch diameter end mill, which will go ahead and machine right around CS number 2 part. And this time we'll use Profiler. We're going to start right there in the center line and tell it to do it. And we'll take a look at the cut part render real quickly and see what this looks like for us as we drill the hole, do the contour around this part, etc. See what's happening. Now we talked about placing this onto a 4-axis horizontal mill. So as we do, we're going to clean up house here a little bit. Then the next thing we want to do, excuse me, wrong button. The next thing we want to do is we want to go ahead and switch machines. So we're going to place this onto a 4-axis horizontal mill. Make sure we're facing straight up for a B-axis indexer that's centered at X0, Z0. And save up what we've done so far. Now the next thing we want to do, from the isometric view you can see the setting. We're going to go ahead, place this part into the body bag. We're going to rename this part. So as we do, we'll type in the name part. Then we want stock. So let's go File, Import, Stock, open this up and bring it in. And this piece will be our stock body. So let's go to the properties of this. We'll name this stock, and we'll set this to stock display only. Now the next thing we need to do is switch coordinate systems. So as we do, we're going to place a tombstone into the picture here. I want the tombstone to belong to coordinate system number 1. So let's open and import the tombstone. Now let's do a view shrink wrap, and if we bring the part back out, and let's rotate the tombstone over. Remember our original origin was down here, and if we bring the part back out, you can see it's down here where it doesn't belong. So switching to coordinate system number 2, we're going to modify the location of where this coordinate system is stored. And what we want to do is we want to move the origin of the coordinate system to x minus 2.75, y 6 inches, z 5.75. Do it. Notice the coordinate system on the screen has moved up to the location we specified. Also the part did, and also the stock. And if we bag the stock, let's go ahead and bag that. Now as we take a look at the machining operations, double-clicking operation number 1, you can see down in this area it has moved with the coordinate system. Also operation number 2, and it has also moved with the coordinate system. Again, one of the beautiful pieces of flexibility with the Gibbs CAM software. Now before we move on, let's change the properties of a couple of things here. The fixture, the tombstone, let's change the properties to fixture display only. Now what we want to do, we'll place these pieces into the body bag. We're going to go to the plugins, toolpath, TMS for Tombstone Management System, Setup TMS. Now what we want to do first is we're going to tell the software the mode we're working in. Is it turned off? Is the Tombstone management system turned off? Are we running a single part, or are we going to run multiple parts? We're going to run multiple parts, and let's click OK. And it's warning me I haven't finished this menu. Let's tell it yes, that's okay. The reason I went ahead and jumped out of the menu is because I want to show you the icon for the Tombstone management operation automatically defaults to land in the first position. Let's open this one more time. We know we're running multiple parts. Over in the count for multiple parts, ultimately we want to run 3 parts on the x-axis. These parts will be centered at 2.75 inches on the x-axis. And the machining operations we want to start at the x0. On the y-axis, we're going to run a total of 3 parts centered at 7 inches, and again for the machining to start at the 0 location of the first part for the y-axis. On the b-axis, we're going to run a total of 4 sides at 90-degree increments, and we'll let it run parallel to the x-axis first. And as we come down, how are we going to group the machining operations? Well, we only have 2 machining operations, operation 2 for the drilling, operation 3 for the contouring. Very simple setup here. We're going to tell it we want to do this by tool, group. Notice the group numbers. Group number 1 includes operation number 2. It can include other operations, but for right now it's going to include operation number 2, which was the drilling. The second grouping is operation number 3 for the contouring. Let's tell it OK. Now it has all of the information. We're going to jump right in. We can close this coordinate system menu. We're going to jump right into the machine simulation. So as we do, we can see the Tombstone, the one stock body. Let's bring in the machine. So we'll load up a machine, 400mm pallet on a horizontal machining center. Again, you know that we need to run 3 across X, 3 up Y around 4 sides of the Tombstone. So let's jump into the plugins. We're going to Toolpath, TMS, Setup Stock and Fixtures. In the body bag, this stock body, we're going to select it. We're going to tell it use the stock. We're going to tell it on the x-axis 3 inches. There will be 3 of them, centered at 2.75 inches center to center. Put the first one at x0. On the y-axis, we want a total of 3 pieces, 3 stock bodies, centered at 7 inches center to center. Place the first one at the original origin 0 for the y-axis. B-axis, again 4 sides, incrementing at 90 degrees. Place the first stock body at the B0 location. And let's set the machine. Now out here on the screen you can see where the stock bodies will be located. We're going to close this menu. On the cut part render for the machine simulation, we're going to stop it and rewind it. And notice now the machine is completely loaded. Let's turn this around and take a look at what we're seeing here. So back into an isometric view, we'll zoom this up and let's slow down the cut part render, and we'll run the cut part render. So you can see the drilling operation running parallel to the x-axis. Indexes to 90 degrees, runs 3 across the x-axis from the bottom to the top of the tombstone. Notice each time it indexes, it starts at that bottom left corner and runs parallel to the x-axis. I do not particularly care for the way this is running. So first we're going to switch this, ask it now repeat on the y-axis first, and let's tell it OK. As we do, we'll rewind this, run the cut part render one more time from the beginning, and notice now it runs parallel to the y-axis. But each pass, it starts at the bottom of the tombstone and works its way back up. Still not the most efficient machining method. So we're going to pop open the Tombstone management and we're going to ask it now the direction. We're going to stay parallel to the y-axis, but the direction, zigzag, up and down the y-axis, and tell it OK. Rewind the cut part render, start from the beginning one more time, and notice now the toolpath zigzags up and down. Notice as we index to 90 degrees, it started in the bottom left corner again at the B180. So still not the most efficient toolpath. Let's open up the Tombstone management one more time. This time we're going to ask it zigzag on the Y, but also zigzag on the B axis. tell it OK, rewind the cut part render, and start it from the beginning. So now we're zigzagging up and down the y-axis. When we index, the tool stays put. Starts at the top right corner. Doesn't make that extra wasted move in the air. Starts at the bottom left corner. So we're zigzagging up and down the y-axis and also the b-axis. Now let's take a look at the Tombstone management menu one more time. We're looking at the retracts between operations, between one location to the next location on the same B face. We're indexing or retracting out 2 inches. Let's change that to 1 inch. That should be sufficient to clear the clamps. Now if we're going to a new B location, it's retracting out 10 inches. Let's change this value to 7.5 inches and tell it OK. Let's stop this one more time and rewind the cut part render. Now notice the new clearance values. And as we do, we can go ahead and index this around for you, the picture, without having to rewind. And we can do it with the center mouse button, do the same thing. So now we have nice efficient toolpath, nice efficient clearance moves. Let's take a look at one more thing. Pop open the Tombstone management. Now that it's time to, we're satisfied with the machining operations and it's time to post-process the code, we can go ahead and optimize how the code is output. Sub mode output. Do we want to put 1 sub per group? Do we want to put 1 sub per operation, 1 group plus can cycle? And we'll go ahead and leave that one alone. Do we want can cycles in the sub or in the main? Let's leave them in the sub. The B-axis output. Do we want it linear or do we want it to wind up to 360, down from 360? And we'll go ahead and leave that. So at this point this is ready to go. Let's resume the cut part render here and let you see what's happening here. And we'll go ahead and stop this demonstration here in a second. So you can see the milling operations that are happening now, everything that's going on. And again, you can zoom in and zoom out, no rewinding. Thank you. I hope you enjoyed the demonstration.